Now, let's look through the solutions of the algebra work that I gave you to look through on Monday. So the first question was question 15 on page 71. And this is a good question to really get to grips of how we would apply what we learned about writing our quadratic equations in completed square form. So part 1 asked us to use the maximum point of the path, PQ, to complete the equation. So they gave us this equation, f of x equals q minus 0.1 times x minus p squared. Now, regardless of what numbers we have anywhere else, let's just write this a little bit turned around so that we've got the bracket first, minus 0.1 times x minus p all squared plus q. So remember that we change the sign of the one in brackets and we don't change the sign of the other one when the maximum point is PQ. So the maximum point here, the x value is 6 and the y value is 4. So filling into this formula now, we can say that f of x is minus 0.1 by x, change the sign of this one, minus 6 all squared, don't change the sign of this one, plus 4. So that's why there was a minus in the formula to begin with, to help remind you to change the sign of the x value. So that was part 1. So part 1 gave me my quadratic in completed square format. Next, they asked us to solve the equation. So for part 2, we have to solve f of x equal to 0 to find these points here, where it's actually crossing the x-axis. So this whole thing, minus 0.1 times x minus 6 all squared plus 4 is equal to 1. Now I can go ahead and multiply out my brackets and solve it using the minus b formula, and that will be correct. But completed square format actually gives us a shortcut for solving as well. I bring the plus 4 over here and it becomes minus, and then I change the signs. This is a single term because they're both multiplied together. So this becomes plus and this becomes plus. And then I want to get rid of the 0.1 just so I only have a square here, and I divide across by 0.1. So I've got x minus 6 all squared equals 4 divided by 0.1 is 40. Now, I've got a square on this side and I don't have a square on this side. To get rid of the square, I want to introduce a square root. But remember, when you introduce a square root yourself, you need to put a plus or minus in front of it. By the way, if you find this more difficult and not easier, then just multiply out the brackets and use the minus b formula. You'll get the same answer in the end. So the square and the square root cancel. X minus 6 is plus or minus. The square root of 40 gives me 2 root 10. You can just put that into your calculator. I'm going to double check it. The square root of 40 is 2 root 10. And then I leave the plus or minus there, and now I'll bring my 6 over. So x is equal to 6 plus or minus 2 root 10. Let's just check if we've solved that. Leave your answer in square root form. Well, we've got that then, okay? So those are my two answers. X is equal to 6 plus 2 root 10, or x is equal to 6 minus 2 root 10. And they asked us to leave our answers like that. To check them though, check if they make sense, I know that the smaller one should be close to minus 1. So when I put that into my calculator, 6 minus 2 root 10, and press my change button, I get minus 0.32. And that makes sense. So minus 0.32 to 2 decimal places. And when I put in the plus into my calculator, and remember, we can just go backwards like this, delete the minus and change it to a plus, and we get 12.32. 12.32, and that makes sense based on the graph that I was given as well. Okay, the third point then. The third question asked us to find the horizontal distance travelled by the ball, and to give our answer in square root form, in surd form. So I'm looking for if I call this the point A and this the point B, I'm looking for the difference between A and B, or the distance between A and B. And so it's just the bigger one minus the smaller one is going to give me that answer. So B minus A will give me the distance travelled. So I have 6 plus 2 root 10 minus, now remember I have to minus both parts of that, 2 root 10. You can use your calculator from here, or 6 plus 2 root 10 minus 6 minus minus gives me plus 2 root 10, and the 6's cancel, giving me 4 root 10, which is what was the format that I was asked for. Let me show you how to do that in the calculator. 6 plus 2 root 10 minus bracket 6 minus 2 root 10, and come out from underneath the square root sign before you close your bracket, and we get 4 root 10. So we can just use the calculator to do it as well, but you can see using algebra techniques we can work it out there as well. Okay, so that was everything in question 15. Let's take a look at the other two questions that I gave you as well. So you had question 1 on page 90. Page 90. Actually, before that you had question 7. Question 1 was actually in the revision exercises. So question 7 wanted us to use the discriminant to determine the nature of the roots. So remember, the discriminant is b squared minus 4ac. That's what we're going to be using every time here. So the discriminant here, I'm just going to call it d, is going to be b squared minus 2 squared minus 4ac. Where are those numbers coming from? Well, a is the x squared coefficient, b is the x coefficient, and c is the constant. So you can put that into your calculator in one go or work it out in your head. That's going to be 4 plus 20, which is 24. That's greater than 0, so that means real distinct roots, 2 different real roots. And that's the kind of answer we're looking for this question. Part 2, I have x squared minus 4x plus 6 equal to 0. We weren't actually asked to find the roots, by the way. We were only asked to state what type of roots they were. So my b squared minus 4ac here is minus 4 squared minus 4 times 1 by 6. And that's going to be 16 minus 24. Minus 8, I think. Yeah, negative 8. Negative 8. So we have imaginary roots. That's less than 0. Imaginary or complex roots. We haven't done complex numbers yet. We do sometimes call them complex roots. And next, part 3. We had minus 6 plus 4x minus x squared. Let's write that in x squared x constant order so that it looks like what we're used to seeing. I could change the signs as well. So I have a, b, c, and my discriminant is b squared minus 4ac, like that. In fact, upside down always has real roots because no, not necessarily. Sorry, that's squared, so that's 16 minus 24. This one has imaginary as well. Let me just double check it on the calculator. 4 squared minus 4 by a negative 1 by a negative 6. And we get minus 8. So that's minus 8, and that's less than 0. So again, we have imaginary or complex roots. Complex is the better term to use here. So we'll start to get used to that. Okay, so that was using discriminants. And question 1 in the revision exercises on the same page asked us to express this in completed square format. Now, it's going to be no surprise to you that I am going to ask you in the assessment on Friday to write some quadratics in completed square format. So I want this written in the form a by x plus h all squared plus k. We know straight away that a is this, so this is going to be 2 times x plus h all squared plus k, and then we square out our brackets. 2 by x squared plus 2hx plus h squared plus k, multiply through the 2, and we get 2x squared plus 4hx plus 2h squared plus k, and that's equal to the original quadratic there. So now my x squared terms are equal. My x terms tell me that 4h is negative 4. So h is equal to minus 1. And my constant terms, these ones here, tell me that 2h squared plus k is equal to minus 5. But we know that h is minus 1, so h squared is 1. So 2 plus k is equal to minus 5. You can fill it in or you can do it in your head. K is equal to minus 7. And I'm not finished until I fill it back into my formula up here. So 2x squared minus 4x minus 5 is 2 bracket x minus 1 all squared minus 7. And then I know that my minimum point is going to be, I change the sign of the 1 in brackets and I don't change the other sign. So they asked us to find the minimum point of the curve. That was part 2. I just wrote it down now. And they also asked us to solve this equation equal to 0. So 2 bracket x minus 1 squared minus 7 equal to 0. And we're going to use the trick we did the last time. So 2 bracket x minus 1 squared equals 7. X minus 1 squared is 7 over 2, or 3.5. And then square root both sides, but introduce a plus or minus. So let me finish it over here. X minus 1 is equal to plus or minus 7 over 2. So x is equal to 1 plus or minus root 7 over 2. And it's fine to leave your answer like that. And my 2 answers are included there. Unless I'm asked to give it to 2 decimal places or something, I don't have to fill it into the calculator. I can just leave it in surd form. Okay, so if you were able to do those 3 questions, you are prepared for the quadratic equation section of the assessment. But remember, it's an open book assessment. So if you see something that you haven't seen in a while, just go through your notes. Okay, thank you.